Our next speaker is Carl Dietrich, who's co-founder and CTO of Terrafugia. Carl received his BS, MS, and PhD from the Department of Aeronautics and Astronautics at MIT. Carl co-founded Terrafugia, the flying car company, shortly after being selected as the 2006 winner of the prestigious Lemelson MIT Student Prize for Innovation. Carl was recognized by the Aero-Astro department at MIT as one of 16 exceptional graduates under the age of 35 and has received 40 under 40 awards from the Boston Business Journal and Aviation Week and Space Technology magazine. He's been a private pilot since the age of 17. His presentation is an introduction to Terrafugia TF-2. Please welcome Carl.
Thank you. Pleasure to be here, guys. So Terrafugia is, compared to many of you, a relative latecomer to electric aviation, but we're catching up fast. So I want to take this opportunity to share a little bit about where we are and where we've been. So Terrafugia last year was acquired by the Zhejiang Geely Holding Group, the parent company of Volvo and Lotus, and a number of other global brands. That has allowed us to expand dramatically over the past year. We now have 3 facilities around the world, an R&D center in California that I run. Our headquarters in engineering is in Massachusetts. That's our largest operation. And we're in the process of setting up a production facility in China right now. We have technology development projects underway with both Lotus and CEVT, which is a lot of Volvo engineers. And our first product will be launching late next year, which we're very excited about. This is the transition that's been in development since 2006, so long time. But our mission truly is to turn that dream of personal flight, the flying car, into a reality. So just very briefly about transition. Many of you have seen these specs. We do use the Rotax 912IS engine. The big announcement that came out last week is that we have incorporated a hybrid electric ground drive into the transition. That system has been under development for well over a year now. So it also has a motor generator on the prop shaft. So that can allow us to give a little extra boost, which for a dirty airframe is a really nice feature to have. So it's a great thing. We're really looking forward. It's going to give our company some very practical hands-on experience with a relatively low power system that's not critical for flight, but it is designed to be on an aircraft, right? And there are a lot of things that you have to do that. So we invite you to come out and see our booth. We will be in the Innovation Center at Oshkosh, so come say hi. Okay. The reason that I'm here, though, is to focus more on the future, looking ahead to the next generation. And we do agree with Uber and many folks in the room that there is a huge latent demand for this urban on-demand mobility if we can overcome the barriers, which are very substantial, to realizing this urban on-demand air taxi market. I borrowed this slide from the Uber guys because I love the graphic here. Some major challenges. There is very limited vertiport infrastructure in these densely populated urban areas that really are the source of very concentrated demand for these eVTOL operations. And in those densely populated urban areas, there is significant sensitivity to aircraft operations. We look back at the Pan Am helicopter accident in the 70s that really dampened any sort of helicopter flying in Manhattan, in an right over Manhattan. It's a huge issue. And it's an issue that we as an industry need to acknowledge and set a very high bar for operational safety and low noise. So the special needs of this emerging market, we need VTOL because we're not going to be able to put in 3,000-foot runways in the densely populated downtown centers. We need a different noise signature than helicopters, much lower noise signature than helicopters. We need much higher reliability and safety if we're going to be flying over densely populated urban areas at high rates, and you really have to do that in order to achieve a practical return on investment. So you're talking about Part 25 or Part 29 levels of reliability, not Part 23, not what we're used to, if you want to have a sustaining or growing industry. And that is a huge challenge in terms of the level of redundancy that you have to architect into the systems and the weight penalties that are associated with that. And you're doing all that in a VTOL, by the way, which is super sensitive to weight. So it's a major, major challenge. And of course, even if you had a technical solution, our air traffic control system is not set up to handle more than maybe half a dozen helicopters over an urban center at once, right? So this is a very huge barrier that they're already up against down in areas like Sao Paulo. And of course, aircraft certification standards are not quite there. We're on the path. There is a path forward, thanks to pioneers in this room, that there will be a path to certify electric aviation, but it really hasn't been exercised yet in terms of the certification. So what you have here is a situation of compounding uncertainties, right? And this is very difficult to predict when things might happen, which means that from an investor perspective, or from our perspective as a company looking to potentially address this latent demand, it's highly speculative, but very interesting, right? So systemic change will be needed, and we have looked at a lot of these local market analyses. Obviously, Uber has a tremendous database that they can use, and I hope you guys have looked at this. But this is one case here, since we're near Chicago, where you see commute times during peak hours. This is a morning rush hour time where you might have a trip from O'Hare into downtown that could push, between an hour and 50 minutes. That's huge variability and just a huge amount of time for a flight that could be 6 minutes in an eVTOL aircraft, right? So, and by the way, even at helicopter pricing, you could charge like $30 per seat for that, and there are a lot of people that would pay $30 per seat, even at helicopter pricing rates, right? If you were allowed to operate that, if you could do that at the volume that's expected. So these are the big issues that I think we have to address for this emerging industry. So with that, the things that we're focused on and our kind of unique approach to this eVTOL space, which now has upwards of 100 players in it, is first, we are very interested in looking at how the Part 135 operator is actually going to operate these things. If you assume that the latent demand is very high and you have approval to operate in these areas, that's an incredible accomplishment, right? Once you get that, some permission to take off and land at a couple locations at least, you want to maximize that, right? Get every dollar that you can out of that operation. So how do we do that? Well, we really have to minimize the turnaround time. Minimize the time that a vehicle is stopped on the ground and not generating revenue for the operator. It's basic airline economics, right? So that it's just scaled down. And those turnaround times have to be a whole lot faster than an airline. This is a type of operation that I think, frankly, we haven't seen in aviation. Even small regional airlines don't have to turn around as fast as what will really help make money for these urban eVTOL operators operating out of these little pads. We need to ensure robust, safe, near all-weather operations. If it's only VFR, it's not really an air taxi. It's not going to display. It's great when you can do it, but if you can't count on it, and the general public doesn't understand most of the aviation constraints, they know even commercial aviation is occasionally grounded. They hate that, right? And commercial aviation is fantastic compared to what we deal with in GA, right? So how do we achieve a level of operations that is almost as weather insensitive as commercial aviation? That's a huge challenge in a little vehicle that is probably going to have lower wing loading than a Part 25 airliner, right? That's a major, major issue, right? So I'm just sharing what our focus is on. So for the economics to really be viable, we do believe that you have to carry more than a couple people, looking at our financial model. So our baseline concepts are focused on 1 pilot and 4 paying passengers. And that also helps, of course, with throughput out of your limited resource, which are these vertipads. We're assuming standard vertiport construction, a helipad that's like 50 feet in diameter, that kind of thing. And this looks like what you might be able to achieve with the types of disk loadings that we're talking about. And then finally, because we're Terrafugia and we're focused on integrating the ground and the air side as much as possible, we do want to try to provide a true door-to-door solution. So you get in the vehicle once and you don't get out until you're at your final destination. Now that said, with all of these challenges, we're not trying to incorporate it all into one vehicle, right? Many of you guys, and I think Willie, you shared our TFX concept. And this was a concept that we looked at a couple of years ago, and it helped us get our arms around the challenges of eVTOL. And it helped that we had an investor that really wanted us to dive into that and let us dig in and really experience firsthand what we were going to hit our shins on. So we did that design study. Now we've learned a bunch of lessons. Now we're going to come back and do something that we think is a little bit more practical for this emerging market. So our concept for TF-2 is actually a 3-part transportation system that has a pod that can be transferred between a ground vehicle and a flight vehicle. The pod could be a passenger carrying pod, or it could be a cargo pod. The flight vehicle has a pilot on board, but it also has a sensor package that, and software that will be advising the pilot, and that software will be, in essence, be a first generation of what we would imagine an autonomous flight management system being down the road. But just as Tom said yesterday, the FAA wants data, right? So we're going to keep a pilot on board. The pilot's going to be making the decisions in this product, advised by this software that has all the sensors and what have you. So the software will tell the pilot what the software would have done in this situation. And then we'll be able to look at the situations where the pilot chose to do something different. And at the beginning, we're expecting that that's going to happen a lot. And hopefully over time, that frequency will be reduced. And eventually, we may get to the point where we look at those individual cases and we're like, you know what, the pilot probably should have done what the software told him to do. And at that point, that's when we can start to take this to the FAA and say, hey, we think we've got something that will add safety to our product. We're a long ways from that right now. But we're making a platform on which we can get that data. And that's really the key for TF-2. Similarly, the ground vehicle has a driver, but it does have autonomous docking capabilities, which is sort of like the self-parking routine on cars that you can buy today. Very simple, very controlled. The complexity is very limited, and it's all done inside. The self-docking is all done in a controlled environment on the pad every time. So we are in the concept development phase for our flight vehicles. So you'll notice that in the graphics that we're sharing here, you've got 2 different concepts. We've got a lift plus cruise configuration on the left, and we've got a tilt rotor configuration on the right. And the reason that we're coming out with 2 concepts is that we're actually looking at over a dozen different configurations and things of that nature. And we're going to be making this decision very much driven by conversations with potential Part 135 operators, potential customers. And we don't know right now whether they're going to value the speed and the efficiency of a tilt rotor sufficiently to justify the increased development costs, the increased price in the long run, or whether they prefer just the more simple fixed pitch everything, robust but not as high performance configuration of a lift plus cruise. So we've come out with these 2 concepts primarily to spawn conversation, right? I promise you that our final product will look different than either of these, but we think that these are interesting designs that that we can learn something from by having a conversation around them. It's something to talk about, right? So our ConOps here, see if this will play. So what wasn't shown here is the pod was loaded somewhere else. In downtown, it could be an on-demand type service. It could be a regularly scheduled bus line that just runs into a downtown area. But you move the variability off of the pad, right? The key for consistency is repeatability, right? Get the variability out of the bottleneck. It's lean manufacturing applied to a transportation system. By the way, this is about real time. This animation is close to about what we expect an actual turnaround time would be. Okay, so highlights, it's a door-to-door type service. The passengers load once, then they can get on their iPads or whatever, do work, not have to worry about swapping modes of vehicles until they arrive at their final destination. We achieve more controlled pad operations than if you load and unload in the pad. So from an operator's perspective, this is better not only because we have a very fast turnaround time so they can make more money, we also don't have untrained people wandering around a pad. We don't have, grandpa with the walker taking an extra 5 minutes while there's a plane coming in waiting to land, right? You get all that variability off the pad. Everybody is nicely contained in the pod, right? And that's also made better by the automated pod swapping, right? The automated docking. So consistent transferability, I mentioned it before, but it's applying the basics of lean manufacturing principles to a transportation system, right? This is the bottleneck, the pad operations, right? optimize the bottleneck and maximize your revenue. Right? So these are some concept sketches for what a pod might look like. Can also be used for cargo operations, regional distribution. I forget if I mentioned or not, but we are looking at hybrid concepts. This is not an all-electric vehicle. So preliminary specs, and again, depends a lot on the image in this picture is the fixed pitch lift plus cruise configuration, but the 160 nautical mile range plus 45-minute reserve if we're operating an IFR, 1,100 pounds payload, one pilot and 4 passengers, and operating cost of $400 to $500 an hour, somewhere in that range. And you notice that this operating cost number in bulk is not that different than a helicopter. We are factoring in battery replacement costs with the hybrid. You're driven to different chemistries and all that sort of thing. You're driven to power cells, not energy cells. And you still have an untrivial battery replacement cost, but it's not quite as bad because we've got a smaller pack. So it is a very different problem for this eVTOL than for the kind of training mission that George was talking about, but it's something that we definitely believe that there's huge latent demand if these obstacles, these practical obstacles can be overcome. And we think this type of concept has the potential to really maximize the revenue opportunity out of what will be the most limited resource, which is the vertical takeoff and landing areas. Right? So that's kind of in summary the quick overview in terms of where we are today. We've got a lot of configurations that are in the works. We are expecting to do some preliminary down selection of configurations, do some outer mold line analysis and refinement, do some subscale testing of unmanned aircraft, developing our control routines for transition, making sure we can do it all the way through, even at small scale first, and then scale up. Now, the last thing that I wanted to mention before I run out of time here is some of the key overall industry issues that I think need to be addressed. We need operational safety targets that we all acknowledge that are significantly higher than what is mandated today for Part 23 type operations. And I think this is an opportunity for us as an industry to come forward and say, look, we need this because we want this industry to survive, right? And to work in collaboration with the FAA and figure out something rational, right? But this should be, and it drives system architecture design, it drives so much in the upfront concept evaluation. We need to know what it is, right? So I think this is a great opportunity for collaboration, for discussion. What should be like a 1309 type reliability level that we're designing to for the overall system? What type of operational safety are we targeting? How are we going to achieve that? How do you show somebody an expected level of operational safety for ConOps to get back to what Tom was talking about before? These are kind of the big picture questions that it's really hard to have a forum to discuss just one issue like this when there are about 50 issues that we need to talk about. So I kind of pulled out ones that I think are 3 key requirements. The next one here I'll talk about is the reserve requirements. For an eVTOL, it's less of an issue for us because we're saying hybrid right now. But for the pure eVTOLs that are doing this electric flying, we've looked at a lot of concepts for this. The reserve requirements are an interesting situation because you can, just with today's battery cells, in theory, meet a 20-minute reserve for a really, really short mission. 30 becomes really difficult. 45 is kind of off the table right now for pure electric with today's batteries. Now, maybe Joby and some of the others that are like extremely efficient, extremely high LVD might be able to get there, but for most of the concepts, it's not there. And the other question that Greg and others at Gamma we've been discussing is whether these time-based requirements are actually appropriate for these missions if the flight is like 6 minutes. Should it be, instead of a 30-minute or 45-minute reserve, should it be you need to be able to go down and do an aborted takeoff because that's where you're going to be consuming a lot of power, and then go land somewhere else some distance away? should the reserve requirement be very dependent on the conditions of the day and the particular location where you are, instead of just being an across the board for any type of mission like this, it's got to be 30 minutes or 45 minutes or what have you. Should the language be more tailored and a little bit more rational for these types of things? So I think this is another conversation that we need to have, and it would be ideal if we could come to some sort of consensus on what the rational proposal was. We have something in Gamma Spec 16 that is a basis for conversation. I think we need to talk a little bit more about it. But and then the last thing is something that I think Paul brought this up at a SVO meeting of, I don't know, a few months back, and it really, I think, could lead us eventually to an alternative to voice-based ATC, right? We need a digital data network, and I would suggest that we just agree as an industry on what standards that should be, what protocols, and if we can do that and just voluntarily implement it, we can show an alternative. It's not required, but we can exchange information. I can tell you where I'm going, how fast. I can share a 4D trajectory if I want with the high bandwidth data networks that are available out there. And I would be happy to do that to improve our communal level of safety, right? And so this is another conversation that I think is going to be very important, because we are not going to be able to achieve any sort of rational or acceptable return on investment unless we can scale beyond voice-based ATC. And there's no path for that right now, right? So there's no timeline. So you can't estimate any sort of rational return on investment. We've got to get something like this in place if we want to be able to make the case rationally to an investor, and I think we have an investor speaking later, that this is worth investing in right now, because you can achieve, we know it's going to be this long till we can achieve, 1,000 flight ops a day over a city. Who knows when that's going to be right now, right? Okay, so these are, in my view, the things we ought to be talking about. I hope to talk with many of you about these issues as we move forward. That's it from me. You have time for questions? Or? Okay, great.
That multimodal work, I was going to ask what your method of fueling is like in that ecosystem of, if it's a hybrid, are you putting liquid fuel in while you're changing pods, or what's the plan there as far as managing fuel?
Yes, we are putting, well, actually, our range is so long and our average flight is so short,
you don't have to fuel
that actually we can do, easily half a dozen operations before we would need
refuel.
To fuel or even really worry about it. That's one of the operational questions that, frankly, we want to talk to Part 135 operators about. How much do they want to carry? How much extra weight do you want to carry?
To reduce fueling.
But we can provide a platform in which they can make that decision if they want.
Sure.
Right? So that's.
And I'll just add to your last points about the industry challenges, and you think you would have seen George and I nodding to this, that we shouldn't be competing on safety, and we shouldn't be competing on that UTM equation of, we should all be working together on those two major aspects so that we have this sustainable, growable business. So thanks.
Yeah, thanks.
So I love the intermodal approach. We actually looked at that years ago at Boeing, and at the time we couldn't make it work for a larger airplane, but we never considered at that time a hybrid electric solution like you have. I'm curious about whether you've considered two things. One is the safety aspect of, I noticed both of your concepts use fewer rotors than many of the other eVTOL concepts that we see, and I'm wondering if you've thought through the failure mode analysis to get kind of an equivalent level of safety with a multi-rotor configuration.
Yeah, and to be clear, we are looking at a lot of concepts with a lot more motors and distributed. The reason that we put forward these two was, and actually, in retrospect, we probably should have put forward one with 6 instead of 4 lifting fans, because we wanted the conversation more to be about, okay, are you open to something that is that's going to look to you more like a large toy, or do you prefer something that's more like a V22 or a 609, right? That's more traditional from an aerospace perspective, and how important is the value of speed? That's what we wanted the conversation to be about, and rather instead, so we initially released these concepts at HAI, and we got a lot of that feedback. You probably ought to have 6. And we're like, yeah. So that was that was probably a mistake in retrospect, but I agree with you, and yes, we are looking at other concepts that have more than 4 lifting fans.
Yeah, and the other comment is when we looked at the intermodal concepts, our weights group at Boeing really punished us for the kind of additional weight for the interface structure between the various intermodal elements, and so that's going to be a bit of a challenge for your airframe weight, I think. Yeah,
and our airframe weight is, so a lot of the eVTOL concepts that are out there right now assume like a 30% structural mass fraction, that sort of range. We're up closer to 40-45%. So it is, you do pay a penalty to have that intermodal. Our contention is that there is so much demand in the short range segment. If you can do it, you really want to maximize that. But this is a business hypothesis that we're coming out with, that it's more about maximizing how many people you can move between that limited vertiport, and they can actually afford to pay, $35 instead of $25. That's not a huge, it doesn't, based on our market assessment, for that 6-minute flight or whatever it is, that's not going to be you look at the hourly numbers and it seems, wow, that's pretty high. But then when you consider what the actual passenger is paying, it's comparable to where Uber is, even at these sorts of helicopter type price numbers, because the flight is so short. Right? Yeah.
I have an additional question there, which is, as you're swapping the pod, and even if you're hybrid electric, you will have batteries on board.
Yes.
Are you thinking of swapping the batteries with the pod, because it sure would give you an additional advantage there?
Yeah, we actually, yes. We've looked at that. Yeah. I think that's about as much as I'm going to say.
Hi, Carl. You talked about starting with a pilot and then moving to a non-piloted autonomous version. Do you foresee an interim step where you go through the remotely piloted stage, which is well explored and you have a lot of data from the military? Or do you see that as an unnecessary step between the two?
I don't see it as a necessary step, and personally, I'm not a huge fan of it. But there are other companies that see things very differently than that. I don't like the idea of having a safety critical communications link, period. That's really what it comes down to. I'm just not a fan of that.
Understood.
So
thank you.
But that's a personal philosophical choice, right? That's.
Oh, I just have kind of a lighthearted question or a comment. I'd like to get a hold of your interface control document so I can start my pod customizing company for high-end users.
So I had a question around, you talked about kind of early demand, these use cases where high-end customers might be willing to pay. Is there a way to kind of validate the full system prior to completing the design and productionization of this full system? Is there like any sort of stepwise approach there? Or do you really have to have the full end-to-end system designed and deployed before you get that feedback from even those high-end customers?
You're talking about a market validation, or are you talking about a technology validation?
Market validation there.
The market I mean, so folks like Uber have tremendous access to data, which I think is the best way to start in terms of forming a strategic business plan. But in terms of validation, I mean, the member of the general public does not know the reality of flight until they go up in a small aircraft. What it feels like, how willing they are to feel that way on a bumpy day, and that versus the value of their time. Like, we can make very kind of pseudo-objective statements about, okay, well, these people are paid this much, their time is worth about this much. If they were rational, they would behave in this way. And you can speculate that on bulk that might be true, but that doesn't take into account all of these other emotional factors that are very real that, frankly, I don't know how to get good data on that until you start putting actual people that are not pilots up into actual aircraft with the actual experience. It's a really good question, and I don't have a good answer.
It seems from the public perception and acceptance standpoint that even a bus linked to a helicopter service and then demonstrating this end-to-end system to then get that kind of real feedback, because what we've found is talking to people, they sometimes get terrified of these ideas and just trying to get it accepted before it's there. Yeah. Okay, thank you.
Yeah, very good.
I don't actually have a question for you, but I do have a compliment for you. And I am on the ASTM committee, and I know your wife well. But to think about Part 25 as a requirement in 1309 mentioning, I think that that's a huge thing and a very, very good thing, because people that think that they're going to take an LSA airplane or a Part 23 that's designed for you and I to fly to the $100 hamburger and fly passengers on a routine basis is ludicrous. The FAA will not allow that. I think they're going to stop that. But fantastic job for thinking of everything. That's great.
We don't know that we've thought of everything, for the record.
Well, we haven't made up all the rules yet.
In fact, I can pretty much guarantee we have no idea how much we don't know.
Hey, Carl, when you were looking at these different configurations for the vehicles, what tools did you have at your disposal for assessing the noise signature of each of them? And do you feel like there are, big gaps remaining in that capability? Are there things that you wish for in these tools that you would be able to better model? And then right alongside that, how good of a target do we as a community have on the nature of the noise signature that we need to be shooting for?
We don't have a good one at all. And that's one of the huge questions that at a configuration level is this, we have, for different requirements, we have different levels of confidence that they're well set. And right now the noise one is our lowest level of confidence because it has to do with the signature and all these other things. And we also don't know from a market sensitivity perspective, we know in more mature markets that there is a tremendous sensitivity. There's anecdotal information that in less mature markets, there may be less sensitivity, at least initially. So there's just, we don't know where it has to be. We don't know the impact of it being at a certain level and not at another level. And I think that that's certainly an area where if there was a company out there that really had a rational approach that connected to cities and stuff like that, and hopefully Uber is doing all this right now, but and had some rational way of figuring out good requirements, it would be incredibly valuable to those of us who are looking at these things from a concept design perspective, because we just don't know. We don't have good targets.
Do you feel that the configuration decisions made up front will have a lasting impact on the noise signature of that aircraft, or do you feel it's something that you can fix later on?
We cannot fix it later on.
Okay.
I will say that. You know, yeah.
Last one.
Just another wire. So I guess as I looked at the pod, it actually has some resemblance to the big commercial shipping containers for the aircraft world. Are you looking at that as one of your many roadmaps that you literally are a pod? You get in the car, you go to the local flight, and the local flight back to the transport to the main aircraft, that all the way out, and then now, I guess, as you go up the wealth ladder, I could imagine having a pretty expensive pod that you would travel around the world in, and you would be in luxury from door to door.
We have not done any sort of, you know, are you talking like multimodal, like you would have pods consolidated on some other form of vehicle? Is that what you're talking about? Right. I thought you were talking about, have we looked at moving shipping containers with a vehicle like this, which we have. But Right. Yeah, that's exactly the type of thing that we've looked at. We don't know, again, right now it appears to us that the passenger moving market looks to be larger than the cargo moving market. There may be lower barriers in other countries to do cargo first, but we want to be addressing the barriers to the largest market. So that's where our focus is. Okay, thank you.